is only one perfect solution, but there are clues that will try to trick our team.
Hello there, everyone. My name is Crazy Caleb, and today we're going to be taking a look at Wonder Cipher. So this module has a series of 20 letters present, 20 letters or numbers in this case, present, and what we must do is we must encode this message using a Wonder Cipher. So taking a look here. So for the first step, what we're going to do is we're going to take all the characters from the screen in order and convert them into 5-digit binary numbers using the table below. And we're going to append all numbers to make one large binary number. So each of the characters have their different values here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then Bravo, in this case there is no alpha present, through Zulu and question mark in this case. So starting off we have Victor, so Victor is going to be 11010, 3 is going to be 00011, then Mike is going to be 10011, 4 is going to be 00100, Juliet 10000. Then Juliet, I'm going to break it up into little groups of 4 just to make it easier to determine where we're at. 10000, Quebec 10110, Lima 10011, 10, excuse me. Then 3 00011, then 11100 for X-ray. Next up, Tango is going to be 11001. Then 0 is going to be 00000. Then 1 is going to be 00001. Then Tango is going to be 11001. Then Sierra is going to be 11000. And for our last 5 messages, for our last 5 characters rather, Foxtrot is 01101. Then Sierra is 11000. 3 is 00011. Lima is 10010. And lastly, I messed up somewhere. Hold on. Just make sure where we're at. So 00. Let's just do that little bit again because I probably typoed somewhere. So Foxtrot being 01101, Sierra 11000, 3 00011. Oh right, the space. I forgot about the space. So we were doing fine. Lima 10010 and Golf 01110. Okay, yeah, it's just this little column mark. I always do -1 to give me a good idea of where I'm at, just to make sure that I am not losing track. But obviously, I forgot to include the space in this case. So now we're going to append all the numbers to make one large binary number. So bring this guy up here, making sure to keep it all in order, and bringing you up here now. Let's zoom out heavily, and now what we're going to do. So we have our large binary number for step 1. Step 1 is complete. So now what we're going to do for step 2 is we're going to take this new binary number and convert it into hexadecimal. So normally, for binary cases, I would simply do the actual math, but this is 100 digits long, and I'm not going to be doing this. So I'm going to use base converter in this case, and I would advise the rest of you to do so because this is error-prone, heavily error-prone. So we're going to convert this from base 2, inputting this large number. Surprisingly, our rapid table supports this. So we're going to go from base 2, and we're converting this into hexadecimal, or in this case, base 16. Base 16 gives us quite a large bit, but not as long as before. And so now what we need to do, so taking a look here, I'm going to leave that there for now. So now, what we need to do is we need to make sure that there are 25 digits present, and if there are less, we're going to prepend zeros until the number reaches 25 digits. So in this case, I'm at column 26, and if we highlight everything else, we're currently selecting 25, so this is perfect. We currently have reached 25 digits. So now what we're going to do is for each pair of digits, replace them with a different pair of digits using this table below. The first digit of the pair represents the row, and the second digit represents the column. Now you might be asking yourself, wait a minute, there's 25 digits present. That's not evenly divisible, and there's not going to be like an even amount of pairs present. So what we're going to do is we're going to ignore the first digit of the full hexadecimal number in this calculation, but do not remove it. So in this case, I'm just simply going to put a space between this delta here, and that's what we're going to be working with. So in this case, our first letter will always be, or first number will always be delta, but now these pairs will be swapping in some way, shape, or form. So our first digit of the pair is a row, and the second represents the column. So 0 echo gives us 29, 6 4 gives us 0 2, 8 4 gives us 8 Charlie, 2 delta in this case gives us 6 1, 2, 1 gives us Foxtrot Alpha. Foxtrot 3. Foxtrot and 3 gives us 4 Bravo. 2, 0 gives us Bravo 8. 0 Echo gives us 2, 9. 7, 0 gives us 9, 3. Delta Charlie, Delta and Charlie gives us 7 Alpha. 0 Echo, I believe we've had this before, giving us 2, 9. And lastly, 4 Echo, giving us Echo 9. And just like that, we're going to simply put this guy back together with the first hexadecimal digit. And now what we're going to do is we're going to move on to step 3. And now we're going to take this new hexadecimal digit and convert into Duotrigestimal, which in this case corresponds to base 32. So when in doubt, we're simply going to use base converter in this case because I'm too lazy to not do base converter. Plug this guy in, make sure we do base 16 to base 32 now. Thankfully, Rapid Table supports this. Let's convert it. And now we're going to get a series of little more strings. Thankfully, it's getting smaller each time, and it's not starting off at 100 digits, but it's still quite long. And what we need to do is we need to make sure there should be 20 digits. If they're less, simply do the same thing as before. We would prepend zeros until the number reaches 20 in this case. So we have 20 present. So in this case, we're all good to go. So now let's take a look at what we need to do for this bit. And this is actually the last step of the module, so I'm actually going to put this guy up here. So we're going to use one of the tables below, and we're going to swap each digit, or actually, wait, no. Using one of the tables below, we're going to swap each digit with the number of the different digit, and we're going to take the digit in the position from right to left. So what exactly are we going to be doing in this case? What we need to do is we need to actually convert these guys into numbers, because in this case, we need to convert them back into decimal for this guy. So what we need to do is we are going to simply convert these guys back into decimal. So for those of you who aren't familiar with how, this case, converting letters into decimal, all you're simply going to do is you're going to add 9 in this case. Add 9 to its alphanumeric position. In this case, Quebec is 17. 17 plus 9 is going to be 26 in this case. And then same thing for alpha, 9 plus 1 being 10. Then 8, then 2 for the number, and then we're going to do hotel, which is 8 plus 9, which is 17, then golf, and I'm actually going to break this up into groups of 5, so let's go 17 down here. Then golf is going to be 7 plus 9 being 16, Victor is 22 plus 9 is 31, and that's actually the highest digit present in base 32, so just to keep that in mind, that's going to be the highest it'll go. Kilo is 9 plus 11, being 20. India is 9 plus 9, so it's going to be 18. Next up, Tango is going to be 20 plus 9, in this case 29. 15 is going to be 15 plus, Oscar is going to be 15 plus 9, in this case going to be 24. 5 is going to be 5, 6 is going to be 6, 9 is going to be 9. November is going to be 14 plus 9, going to be 23. Kilo is 11 plus 9, being 20. Alpha is 1 plus 9 being 10, Foxtrot is 6 plus 9 being 15, and lastly we have 9. So now, what we're going to do is we've simply converted these guys back into decimal value, which we're going to submit later. Note that this table uses the decimal value of the Duotrigestimal digit, and now what we're going to do is with this little bit right here, we need to figure out what the light of the module is so that we can simply reorder this module. So the light of the module is red, so we're going to use this table below. And what this wants us to do is we're going to take the digit in the position of the right side of the table and move it to the position on the left side. So in a nutshell, what this is going to be doing, and you only move each digit once, what we're doing is essentially reordering each of these digits present in the module. So taking a look here, so position 15 goes into the first position. I'm simply going to go down each column because that's going to be how we're going to order each position. So the 15th position that we have right here will go into the first. So 15 is 9 in this case. 9 will go down here. 5 is going to go in the second position, which is 17. 4 will go in 3, so in this case 2 will go there. 12 will go, in this case, being 24. 12 will go in the fourth position. 10 will go in the fifth position, in this case 18. 16, 23, so in this case that corresponds to 23 right here, goes in the sixth position. 11 will go into the 7th position, 29. 3 will go into the 8th, so 8. 17 will go into 9, so in this case being 20. 18 will go into 10, being 10. Next column, next row rather, 8 is going to go into 11, being 31. 1 is going into 12, so in this case 26 is going to go into 12 right there. 20 is going into 13, which is 9. 14 is going to go into 14, as you would expect, so 6. Then next up, then 6 is going to go into 15, so 17. And then 19 is going to go into 16, so 15. Then 7 is going to go into 17, so that's going to be 16 right here. Then 2 is going to go into 18, so 10. 9 is going to go into 19, so 20. And then lastly, 13, being a 5, is going to go right here into position 20. And this is the reordering that we have to do. And now for our final step, what we're simply going to do is with each of these decimal values that we've converted from duotrigesimal digits, we're simply going to change these into characters based off of this little key right here. So let's figure this out. So our first character is 9, which is 0. This is a 0, not an Oscar. And the way that you can tell is some of these guys present on the module, and most of these ones actually, will be in red in some way, shape, or form. So that means you cannot simply interact with them at all. And as you can see here, the Oscar in this case is corresponding to red, so that means you're not able to put that into the module, which in this case means it's 0. So next up, 17 is a 5, 2 is a 7, 24 is 1, 18 is Mike, 23, I'm going to space this out, 23 is going to be Kilo, 29 is going to be Quebec, 8 is Foxtrot, 20 is Hotel, 10 is Plus. Next up, 31 is Whiskey, 26 is an equal sign, 9 is going to be 0 again, then 6 is going to be 8, then 17 is 5, and lastly, 15 and 16, 15 Yankee, 16 4, 10 and 20, 10 plus, 20 Hotel, and lastly 5, which is Romeo. And this is going to be the final submission that we're going to submit into this code. So let's move this guy over here. And what we're going to do is we're simply going to press the back button to change the module into the submission mode. And you can simply press the back button again to change it back to the original board in this case, the original message in this case. Next up, let's submit this into the module. So we're going to submit 0, 5, 7, 1, then Mike. Note that we don't need to do any spaces at all, and we have a delete button that we can do here. So if in this case, if you happen to typo one of them, totally fine. There is a delete button present, so in this case, that's perfectly fine for us. So 0, 5, 7, 1 Mike for our first part. Then Kilo, Quebec, Foxtrot, Hotel Plus. So Kilo, Quebec, Foxtrot, Hotel Plus. Plus being down here. Then Whiskey equals 085. And lastly, Yankee wherever it is, Yankee 4 plus Hotel Romeo, HR. And just like that, we're going to submit the module, and it's done. Let's take a look at one final example. This module is a bit longer on the end, but the work itself is not tricky. It's just very long. So let's take a look here. So let's convert all of these guys into binary, once again. In this case, I'm just going to do this silently by myself, so I don't have to repeat 1s and 0s all the time. Alright, first half done. Next up is 4. Okay, now let's combine all of these guys together. Alright, let's just copy this entire row right here. Get you up here, zoom out. Alright, and now let's copy this into the base converter here. So we're going to go from base 2 to base 16 in this case. For this stage, let's copy you in, large binary number incoming. And this is going to be our hexadecimal right here. So we need to make sure that it is 25 digits, which in this case it is. Yep. Because when we highlight all of this, we're simply selecting 25 letters, so we're good to go. So remember, we're going to ignore the first full digit, and we're going to take a look at the table here. So remember, Foxtrot will still stay the same, but we need to figure out what the pairs for the rest of these guys are. So we have Bravo 3 being 0 Charlie, and 3-7. 3-7 being Alpha 4, and 1-8, or 8. Bravo Foxtrot, Alpha Foxtrot, 5-3, 9 Bravo, then 0-9 to Alpha, 5 Delta, 5-1, then 9 Echo, Alpha 6, Charlie 2, 0 Delta, 5-8, 4-1, 1-2, 9 Delta, Delta 8, for our last pair, is Foxtrot Foxtrot. Now let's combine this all back together. And now what we're going to do is we're going to convert this from base 16 to base 32. Using this hexadecimal number, get this guy out of here. Convert this from base 16 to base 32, giving us this guy. This is indeed 20 digits present. We don't need to put any zeros before it, so taking a look here. So let's convert all of these guys into decimals to make this sorting life easier, so that we can submit this into the module. So we have uniform, so 21 plus 9 is 30, 3, 5, 4, 9. Thank you very much for decimals, for numbers in this case. 2, 14 plus November, excuse me, 14 plus 9 is 23, 16 plus 9 is 25, yes, 13 plus 9 is 22, then 10, then 18, then 17, then 20, then 24, then 6, yep, and then last 5, then 20, then 3, then 7, then 15, then 31. Alright, and now the decimal is red again. It's between either blue or red that you can get. And now we're going to reorder it like this right here. So we're going to do 15. 15 is 6. 6, and then 5, and then 4, and then 12. And remember, I'm referring to these as positions, not values in this case. So then 10, 16, then 11, then 3. We break this up into groups of 5. I'm going to do that. So then 3, then 5, 17, 18, 8, then 1, then 20, then 14, then 6, so 2, 19, 7, 2, and lastly 9. Or excuse me, 9 and then 13. 22 and then 13 being 20. Alright, and now let's convert these guys back into characters. So 6 being 8, 9 being 0, 4 being Papa, 17 being 5, 10 being plus, next up 20 being Hotel, 18 being Mike, 5 being Romeo, 3 being November, 7 being 9. Next up, 25. 25 is 2. 30 is an and symbol, or an at symbol, like the email. Then next up, we just did 30, so 31 is whiskey, 24 is 1, 2 is 7, last little bit, 15 being Yankee, 23 being kilo, 3 being November, 22 minus, and 20 or dash, and 20 being hotel. And now let's submit this into the module. Back down here. So we have 80. Let's back out. 80. Papa 5 plus. Then Hotel Mike. Romeo November. 9. Then 2 alpha. So 2 and the at sign. At sign in this case. Whiskey. Then 17. Then Yankee Kilo November minus hotel. Yankee Kilo November minus being down bottom left, and then hotel. Let's submit the module. And just like that is the solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.